we'll learn about time complexity. The first thing, first optimistic thing in data structures and algorithms. So before knowing the data structures and algorithms, we have to know what is time complexity, what is the term time complexity, and there are certain things that I'll discuss in this video. So please watch till the end of the video. We'll discuss about big O notation, asymptotic notation, best course, expected case, and this is the most important term while you do some interview questions or you should solve some programming questions. So let's start. What is time complexity? So if I ask anybody who had done programming what is time complexity, he will say one thing certainly, that you have a input, you have a output. So for generating the output from the input, the time we needed, that is basically called time complexity. I mean, he will say that just think about, there is a block of code, and for executing this block of code we need something 0.001 millisecond. He will say that this is called time complexity, but this word and this uh, statement is absolutely wrong. Why wrong? I am saying this. Okay. So basically, time complexity is nothing but the time needed to execute a block of code. Basically, the developers or the programmer didn't think about, or didn't care about the time that needed to execute a program, because this certain time to be executed at certain code, that will be vary from a machine to machines, and as well as a language to languages. So if we work on Java, that time their execution time would be something 0.1 is 0.x. It will be Python, there will be 0.y. If C, there will be a certain number, and this certain number will be vary from language to languages and machine to machines. So what is the optimistic answer of a time complexity? The basically optimistic answer of time complexity is, when the input, just think about one thing. uh, I have one input and one output. So at first I'll see this certain program. Time complexity is not about the time needed to execute a block of code, but it means how runtime grows when the input grows. What does it mean? What is runtime? What is input? So for discussing this, I have to take some example. Okay. So there are some, just think about one thing. You have gone to a product based company, and there the manager have given you a certain elements for being sorted, for being searched. What is searching? So it is basically a sorting algorithm. Just think about one matter, that you have 10 elements. I'll discuss about. Just think about one matter. You have one array, and in one 20, 25, you have certain numbers. So this is 0 index, this is 1, 2, and so on. So now you have told to arrange, okay, to arrange in ascending order of this certain code, and you have made an algorithm, and you have told to do it for 10 elements. You and your friends, just think about one matter, that your name is Subham and your friend's name is Ritik. So Subham made an algorithm of arranging 10 elements in ascending order, and Ritik have also made a certain algorithm to sort, or to sort 10 elements. So in that 10 elements point of view, so I think that the 10 element sorting is being cleared, because there are certain 1, 2, 3, 4. Just think about one thing, that you have a random data, you have a big random data, okay, and you have to sort something, like there is not in, I have just mentioned it in ascending order. So just think about, that is not in ascending order. There are two, there are one, there are five. Just think about, there are arbitrary number and each sorted number, unsorted number, and you have to sort that certain elements. So for that sorting point of view, Subham made a certain algorithm, Subham made a certain program, Ritik made a certain program. For that certain program, he needed 90 milliseconds to execute that certain time, certain element, to sort that certain elements. And Ritik also needed 122 milliseconds. So in this 10 elements point of view, what will be your what will be your observation that whose algorithm is best for sorting just 10 elements. Just forget about these terms, these terms, these terms. So in that point of view, you can easily say that Shubham algorithm is the best because it needed shorter time to execute or to execute the certain program, to execute that certain target. Now come on the 70 elements. If you give 70 elements to Shubham and Ritik, Shubham need 110 milliseconds, Ritik need 124 milliseconds. You also say that yes, Shubham's algorithm is the best because he needed lesser time. Now it is increasing, and for 110 elements, Shubham algorithm need 180 milliseconds, and but Ritik's algorithm need 131 milliseconds. Now we can say that yeah, maybe there will be some issue, that's why, but there is some average point of view, and you will say that Ritik's algorithm is the best for 110 elements point of view. Now there is a big data, there's a big data in your database, and you have asked to sort that data for Shubham and Ritik's algorithm, and Shubham's algorithm has been taken a big time, 2 seconds, and Ritik's algorithm has rigorously and certainly reduced huge time, like 800 milliseconds. So, for lesser number of elements being sorted, Shubham's algorithm is the best. No issue, no problem. But for but when the input is being increased in 1000 elements, Ritik's algorithm has been rigorously became better. So we can say Ritik's algorithm is the best, and this is the thing we have studied before. In this portion, time complexity is not about the time needed to execute a certain block of code, but it means how the runtime grows when the input grows. So basically, time complexity is none but a function that derives that when the input grows, how the runtime of the output grows, or how when we increase the elements, when we increase the number of inputs, how the runtime will increase, and what will be the functions of being the runtime increased. I think that is clear. Okay, so I'm going to another example. That previous example was a certain example. Now we'll discuss another example, and I want that this time complexity thing will be clear, will be crystal clear for every of you. Okay, so let's think about one easy intuition that you and this is your friend. Okay, so now you have one. Just think about that. That there is summer vacation, and you have two games. One game is 100 KB. One game size is 100 KB. Another game size is 5 GB. So this game is just think about this is GTA, and this is any random easy game like Snake game. I don't know any game that is below of 100 KB size, so I just say that game one and game two. Okay, and you want to send it to your friend. But there are some catches. What the catches? The distance between you and your friend's house is 5 kilometers. So you cannot open your door or open your window and send the hard disk or send the game to your friend. You cannot do that. The distance of your houses is 5 kilometers. So you have to travel through some bus or some vehicles, or you have to go through a bike, and you have only you both you and your friend have only limited data. So just think about that, you guys are using geo 1 GB net, 1 GB per day, so you have limited data. So what will be the intuition of being sent the two game of your friend? I think what will be the what will be when you want to send this game one to your friend. Literally, you will say that if I just waste my 100 KB for being transform this file to my friend's file, there will be no issue because you have 1 GB. So you can easily, send this certain file to your friend 100 KB. So you will use internet. You will use internet, INT. And for sending this big size game 2, that is 5 GB, you need maximum data, and There in the caches there is, you have only limited data source. You have only limited data source. You have only 1 GB data that is limited. So you cannot send it via internet. You cannot send it through internet. So what you have to do, or your friend have to do, your friend have to come to your house by travel, by using some vehicle, and he had to copy this certain game on your hard disk, and he had to go his home. The same process that will be if you want to come his house, and the same process vice versa. I'll take only these options. So what are there? There will be two algorithm. This is algorithm 2 and this is algorithm 1. Okay, so one thing, what is algorithm? Algorithm is basically nothing but a step-by-step intuition to do a code, or intuition to execute a certain block of code, that is called algorithm. Algorithm is a step-by-step optimized process. While we will take a rational decision, we need an algorithm via which we could make our decision rational. Okay, so that is called algorithm. We'll discuss it and in the next video, or I just want to up to the next video. Okay, so now you have algorithm 1, you have algorithm 2. Throughout algorithm 1, you have, or you will transfer this certain small size data or small size game to your friend via internet. Okay, and in algorithm 2, you will transfer, or you will, or he, your friends will come to your house and certain copy this game on his hard disk and go use his home. And point to be noted, he has to travel and use some vehicles. So now, what is algorithm 1? Algorithm 1 is, you can see, for a big size game. Okay, so I have just one thing. This is algorithm 2 and this is algorithm 1. Okay, so let's do it. So for algorithm 1, for a big size game, the best way is to go his home and copy it in his hard disk. Okay, you could go his home, or he could come in your home. That thing will be same. So now, what will be the conditions? Just think about, this is your home. I'll take its age, and this is your friend's home. Your friend had to travel 5 kilometers. Think about that, your friend had to come by vehicles like bus, like just think about one matter, that your friend has came into your house. That thing is not, I want to make this intuition that that time is not too small. For traveling 5 kilometers, he need to be approximate of an hour, minimum 1 hour he needed to travel. Okay, there will be jam, there will be certain thing, I will just make that thing, I will ignore that thing. And if he come your home, then your mom obviously greet him, or he will make some breakfast for him. That thing is a certain thing. So this time, I want to say that this time, just think, this is 65 minutes. Just think, this is 65 minutes. The time that he needed to come your home, copy that file and go his home. I will just make it 65 minutes. So, and one thing to tell, that uh, the time to download, or the time to copy that file to his hard disk will not take much than or 1 to 2 minutes. Just think about that, you have that file, and he had called that bro, just download that in the file, and I will just come and I'll just take it to my home. So that will not take a time, so I'll just ignore that time. I will only think about the time that he needed to travel. He had to travel your home. What will be the time needed? The bus, your home accessories, or he have to repeat that process. So, is my point is very simple. Just think about, this is t suffix n. Is this t suffix n will depend on the size of the data or the size of the game for which he had to come to your home. Is this time is dependent on that amount of data or the size of the game. Is it true or false? I am saying that is this time needed, this time needed is have any relation, I have made a box, have any relation with the size of the game, with the parameters. Is there any relation? No, there is no relation. It has only a relation with the vehicles. I will just make it with the vehicles, with the home person, so on and so on. There should be other parameters, but there is not happening this certain parameter or this certain conditions. Their conditions that are being fulfilled. So I can say that this is called constant time complexity. I have said that before, that how the input grows when the input grows, sorry, when the input grows, how much, in how much ratio the runtime grows. So if I increase the size of the game, if I made it 60 GB, just think about, there will be some program file that will be 60 GB, and he had sent, and he had to come to my house to take that certain hard disk to his home. Would he put this time that will be 5 minutes, sorry, 5 hours, just think about, this is 5 hours. Is this 5 hour depend on the size of the game? No. It will increase, you will increase this, but this will be constant. If I plot a graph, if I made is the size of the game and this is the time. So if I increase the size, just think about, this is size, this is size, this is size, but for every condition the t is constant, for every certain condition t is constant, for this t will be constant, for this t will be constant, for this t will be constant. T will not depend on the size of the game. That is clear? Yes, that is clear. In the algorithm 2, what will be in the algorithm 2? You have a 100 GB, sorry, 100 KB file, and you have to just send it via internet. Now, for a small size game, I should send it through Dropbox or through email, or through, if possible, I can send it through WhatsApp also. Limit that sort of thing. And I also send it through mail or something. There'll be so many things to do via internet. One thing to say, that will be via internet. That, okay, that should be via internet. So now, for a small size game, I should drop it on the Dropbox, or I will send it on any internet based program. So now, one thing to remember, in these conditions, just think about that the sending time is tn. Is this tn depend on the size of the internet, size of the file? Yes, 100% that is true. Why this is true? Just think about one matter, just think about one easiest way. The file that I want to send to him, according to algorithm 1, there will be big O of n square, the time complexity. I will not say you to define that certain thing, but I will just say it to discuss that certain of things. So in these conditions, if we calculate the time complexity big O of n, this is called the, I will discuss it later after this, after completion of this topic. Just just remember one thing. This is called algorithm 2. This is the prospect, and this is the understanding of algorithm 2, and this is the prospect of algorithm 1. So I will just say it that for algorithm 1, the big O of n is what? The big O of n will be certain thing that will not depend on that size of the game. Okay, and for that will be depend on the size of the game. So it will depend on the size of the game. So if the size of the game increases, the time also will increased. I think that should be clear. Now we'll visualize the O. So I need a certain page. Okay, so I need a certain page. uh, what we discussed. That's so I will take and remove, erase it, and just visualize this big O. What is this big O? What is this big O? And the symbol of the big O is big O, and this O suffix n, the n is the parameter. Okay, there is the parameter. So now what is the visual? What if the thing out don't matter when this is constant? The big O is constant for for which time? For when will not when it will not be dependent on the size of the game. That time it will be big O of n, and other that will be big O of n square. Just think about this is n square. We have to derive that certain thing from this case. Okay. So there will be, it will depend on the size of the game. It will not depend. So if we plot a graph, so this is time and this is n. N means the size of the game. Okay. So if we plot, at first if we plot the big O of n, that will be constant. I have just said that it will be constant. And for, I will take this. So for this n square, that time the value of the n will be increased of the certain, of spending a certain time. So that will be look like this. I think that is clear to everyone. One thing I will just say it, and I will just say this everything in the next part of the video, in the rest part of the video. One thing to say, that in which certain condition that two lines intersect each other, that point is called n suffix 0. Sorry, n suffix 0. Just remember this. Now I will come asymptotic notation. What is called asymptotic notation? What is meant by asymptotic notation? Asymptotic notation gives us an idea about how good a given algorithm is compared to some other algorithm. We have to compare. What is the compare point of view? Okay. So we have Shubham algorithm, we have Ritik's algorithm. So now throughout the asymptotic notation, throughout the certain parameters of asymptotic notation, we can compare Shubham's algorithm to Ritik's algorithm and vice versa. Ritik's algorithm to Shubham's algorithm if there are so many developers or so many programs dealing with certain sorting program and they have certain execution or runtime. So we'll just compare themselves uh, via which, that is called asymptotic notation. Okay. Now there are some certain thing that is big O. I have said that the term big O, big omega and big theta. Okay. So there are the, for big O the sign of the big O is cap B, cap O, and for omega, big omega, that will be cap omega, and for big theta that will be cap theta. Cap I mean capital. Okay. So okay. So what is big O notation? You can see that there is a big line, big statement. If fn describes runtime of an algorithm, fn is on, and fn is big O of gn if and if only if there exists positive constant c and n suffix 0 such that n greater or equal to n0, and that so on and so on. There is certain conditions. Will I memorize that certain thing? I know. Just try to remember one thing. Big O notation is used to describe asymptotic notation upper bound. Mathematically, it is the mathematical definitions of big O. Now, just think this up. This Fn is a certain program, certain conditions. Okay. So if Fn describes the running time of an algorithm, so for being, so just think about, I have executed a sorting. Okay. For that sorting program, I uses, or I have executed a code and I have executed a result after executing, when the execution time is like, let's say, n square. What is big O of gn? Big O of gn is the time complexity of fn. if fn is big O of gn, if and only if, this is if and only if I double f. Okay, if and only if there exists positive constant c and n suffix 0 such that there is a condition cap n should be greater or greater equal to n0, and there is a certain, I think I know that this will blow your mind. So do one thing. I will plot one graph. This will be the n and this is the time. Just think that you have a certain fn, that fn will be like the thing that fn will be like this. That will be your, okay, so I have done one mistake. Uh, so we erase it and but the fn will be like this. Just see, this is fn, but the big O of n, you can see that the big O of n, I mean the c of gn, the c of gn, c is the constant, c is the certain constant. So the value of c is what? The value of c defines that g of n should be greater or equal to f of n. Just think that if f of n is 2, I will not say 2, just say that if f of n is the n square plus 1 and c of gn, I mean the gn is like thing that it is n cube. So I have to say that prove that that this fn, I mean this n square plus 1 is big O of n cube or is on, is not. So I have to say that prove that or show that n square plus 1 is had a time complexity of big O of n cube. I have to say that this is wrong or this is correct. So I have to do with that certain conditionable problem, conditionable sorry, equation. I have to directly put that fn on here, and I have to put that cgn. I mean I have the gn or this big O of what is inside of this, what is inside of this big O of gn, that is I have to put here. So I will put this n cube and I will just take any number, any positive number. One thing to remember, that will be a positive number. So at first I will take 1. So just put on the value of n, 1 plus 1, 2, 1 cube, 1. That is wrong. That is wrong. The second condition 2, just put it on n, 2 square plus 1. What is 2 square plus 1? 2 square plus 1, 4 plus 1, 5, 2, 8. This is true. For 3, that will be 3, 3 square 9 plus 1, 10. And that will be 3 cube 27. This is true. And this also is true because I have said that there will be certain thing that will there exists a positive constant c. So if I just multiply this with 3, then these conditions remains true and it followed the certain thing. And I will just come on this point why I have said this. Okay, so now if we plot this O of gn here, what will be if we will get this? Just think that we'll get this. So this is g of n. Okay, now what is called threshold? Threshold is a certain point, and that time the value would be equal. So I think that this will be the threshold n0. So this n0 is lower than equal to n, the value of n, the value of this n. I think that is clear. Now coming on big omega notation. Every statement is equal. The statement is equal if fn describes the running time of an algorithm, and if fn is big omega of g of n. If this condition is true, then we have to do one thing. If and only if there exists a positive constant c and n0 such that, now come on this. Just if I just took on there, just think that there will be fn in the middle and there will be fn on the last. So the condition, the two things had reversed. Why that had been reversed? If we plot a big omega curve, just think that if the fn value is like this, this is fn, and I have not put it because it will, this is n and this is the time, this is the time. So the big O of n, so the big omega is like g of n. This is g of n. Now the interesting part is what will be the value of g of n in that certain graph. So if I plot in another color, let's see what I'll just do. So this g of n will rigorously and come on this. This is g of n. According to this law that has been satisfied because it has been reduced, I have got to. So basically, I have made it constant. Laser that will be not like uh, thing like this. Okay. So in this point, this is called threshold. This is N0. So obviously, this condition satisfied. I think there is no truth. If you have to ask, you have asked to do, bro, just do if n square the previous sum, that if check that if n square, if fn is n square of the runtime of a certain program or runtime of a certain algorithm is n square, prove that the time and complexity big O of certain like n square plus 1 or n square, I just give it n square plus 1. You have to do certain thing that please put on gn, here the gn, then square, put n square, make the condition satisfied, n square plus 1, and increase the value of n 1, 2, 3, 4, 5, 6, 7, and see that if this condition being true or not. If that is true, then the complexity is this. If that is not, say no, no, this is not the time complexity. If this is not the big omega of gn, this is called the big omega notation. Now, big theta notation. The funny thing is, big theta notation, when I study in my the big theta notation, big theta notation is equals to big omega notation and big O notation. You can see that if fn describes the running time of an algorithm, fn is theta of n, theta of gn. If I mean when fn is theta of gn, there will be certain condition if and only if when the fn is big O of gn and fn is big omega of gn. So now if just think about, I have just said n square plus 1 is n big omega big O of sorry, uh, big O of n cube. Besides, it is big omega of n cube. That time that will be also big theta of this. Now, what will be the conditions? You know that these two conditions are being true. Okay, that can both, if the both conditions are being satisfied, then we can say कि bro यार ये theta of gn का time complexity में आता है. This is under the time complexity of theta of gn. Okay, so now if we just add that two equation, what will we get? That this will be 0. There is, just think about, this is c1 and this is c2. Okay. There are the constant. If we just call it with k, k1, k2, m, m1, m2, there will be no issue. So this is c and c1 and this is c2. So this is c1. I have said is c1 gn. After that there will be fn. I have written fn. After that there will be c2 gn. Simple, simplest thing. And the funny thing, if is we will we remember that कि हमको रट्टा मानना है, सबसे पहला बात रट्टा नहीं मानना है. We have not to remember that certain thing. So now अगर हमको ये चीज को याद करना है तो क्या करना है हमको? We have to plot a certain graph. From that graph we should mention that big theta. So here what will be the value of the big theta? If we plot a certain graph, if we plot certain graph, the graphical view of big theta, just think that this is the fn, and the funny thing, this is c1 and this is c2. This is c1, this is c2, this is f of n. And you can say that f of n guy is sandwiched between c1 and c2. So what is sandwich? So just think that this is the upper layer of your sandwich, this is the lower level of your sandwich, and here the sausage or the cheese slice or something. So you can say that this fn guy is compressed or sandwiched between c1 and c2. This is the big theta notation. Now one question arises in our mind, which is most applicable. कौन सा जो हम पढ़ा अभी तक बिग ओ पढ़ा, बिग ओमेगा पढ़ा, बिग थीटा पढ़ा, इसमें से कौन सबसे ज्यादा एप्लीकेबल है? Which one is the most applicable one? Which asymptotic notation is the most applicable according to the algorithm? So now, in my point of view, when you have asked to do it on your interview, that you have to say that for asymptotic notation, which algorithm, you have to ask that prove that without any certain line. You have asked that proof that big O of n square is the time complexity of n square plus 1. When you have asked it without any, not the asymptotic notation, which asymptotic notation you have to do. So you have to do it with big theta, because if we do it on big theta, that time the big omega and big O had been completed and had been done within a certain big theta. If that certain thing is true in big theta, that certain thing also be true in big omega or big O. Just think about it. So according to my point of view, big theta is the most important thing. And basically this give a better picture of runtime for an algorithm. So most of the interviewer expect you to provide an answer in terms of big theta. When they say ordered of, when the interviewer asks you order of, I know that in PowerPoint the writing process is too tremendous. Order of. If you are asked to do order of, you have to do it on big theta. Yeah, big theta. That is now come on a problem. So I will not solve this problem. I will say you the intuition, and throughout on the intuition you have to do it. So you have said that bro, you have b n square plus n plus 1 is the runtime of an algorithm, and prove it that its time complexity is this, and this. I will suggest you, for this practice point of view, do that certain thing at first with big O formula, big omega formula, big theta formula respectively. And after completion of that, do it with using big theta formula. What you have to do, you have to do this for big O formula, for big O of n condition. You have to write 0 f of n c of g, and at first you have to write that certain thing, that if this f of n, the time complexity of this is big of n, even only if then constant c, and there will be n greater equal to n0, and the condition is basically this, and you have to put this f of n value, this is will be the value of f of n, and this will be the value of g of n. Just do it with 1, 2, 3, 4, 5, 6, as well as with big omega and big theta. And after completion of that, do it with only big theta. If it is true on big theta, that will be true on big omega and big theta. So, that is good. If there will be any problem, just comment it down. I'll just give you the proper intuition, but I will not solve it. I have just said the intuition and the proper build process in the previous part of the video, but I will not solve it. Okay? That will be your whole task. Now, the increasing order of the common runtimes. We have a certain runtime: 1 log n log n square, n cube, 2 to the power n to the power n. Now this is called base case, this is called worst case. Why this is called base? Why this is called worst? So if I plot a graph, that will be time t. This will be the what n. What will the graph look like? So the good thing, the what is the, or what is the best? Obviously the constant is the best. So this is for the one case. This is for the log n case. This is for the O log n case. Or I mean the L log n case, sorry. Big O of L log n. एखाने B यहाँ पे होगा big O of, okay. And that will be look like this, big O of 2n, big O of n to the power n. The point is, which is why we will call this is base, this is host, and this is host. Let's do. So this is called ORS, this is called based. Constant is obviously based because it will not depend on the certain number of n. It will not depend. Go, yeah, I mean, this one has been told that I will be constant. Please let मतलब size और parameter में तूफान आ जाए, मैं इस one ही रखूँगा, मैं constant और big O of n log n, that will be average. This is average. So depend on that we could mention base case, worst case and average case. Okay. Now I will take another example, analyzing two array search algorithms. Algorithm analyzing two array search algorithm. Okay. So you have to ask that this is an array. This is an array of being. This is index 0. This is index 1, 2, 3, 4, and 5. This is an array of size 6. Array of size 6. And you have asked that search a RAM number. Just think, in my first intuition, I have to search this number 12. It has said that search with the number 12. So there will be one thing that what is called based case. If this number 12 will, so the first intuition, so at first I have to go to the algorithm. So what is the first algorithm? First algorithm is I have to search, I have to compare this element with the desired thing, that desired element is x. So I have to compare that if x is equal to 1, if that is equal to 1, that is very good. I have to not proceed this with the other thing. So I have got with my first step. So that will be based case. And let, if that is not true, go with this. So no, it is not true, that will not true. So come on this. Is x is equal to 5? No, it is not. Is x is equal to 9? No, it is not. Is it equal to 12? No, it is not. And you have to go in algorithm in the sorry, for the index of 5, and you have seen that you have got your desired search. So this is the algorithm that you have to go through the index simultaneously. So the best case would be if you get the desired element in the first index, that will be the best case. What will be the worst case? That you have got it with the index in the last index, and you have to make this process run till the array has been closed. So I've got it in this 5, and the worst case one is also one worst case that you hadn't get that such desire, and you have given an array like 7. The 7 is not exist to this array. So this element has not been found in that search. So you have to work hard. So that will be the worst case. And what will the algorithm do? This is algorithm 1, that you have to traverse. This process is called traversal. You have to traverse through the array, through the index, and you have to search that certain you desire. Now, this is algorithm 1. This is the basic algorithm. But there will be another algorithm. What will be another algorithm? Let's erase this. Uh, okay. So if this process is true for a certain a number 6 array, just think that if this array size is like 1000, then you have to work hard now. You have to go through the each 1000 element for a worst case. For think one thing to be clear, why we calculate only the worst case. Just think that once there is a server, I like to give some example. Just think there is a server. This is server 1, this is server 2. This server is being used by 100 people and this is used by 1000. So who has the highest probability of being crashed? Which server has the highest probability of being crashed? Obviously, in which server having the most number of user. So we'll take the intuition worst with everywhere. We'll not pick it with the best case. Okay, so what will be if there will be maximum number or maximum size of the array? I will break that array or break that certain matrix in such smallest number. At first, do it with array size 6. I will check this first element and this last element. I will check this first element. One thing to remember that in this array I have taken ascending order array. You can also do it vice versa, reversing descending order of arrays. But the point is this array is sorted. Okay, so you have a sorted array. The first is you have a sorted array in ascending order. So now you have not now you are not said that is ascending order, but you have said that this is a sorted array. So if it is ascending order in ascending order, if and else that will be in descending order. So now you will compare this one and this 56 with your desired. Just think that it is your desired element with this and with this. Just think that this is not true. So 1 is not equal to x and 56 is not equal to x. That is clear. You have got the answer that no, your x is not equal to both the first indexing or the last indexing. And now we will compare that which, I mean, x is greater than 1? No. X is greater than 56? No. X is greater than 1? Yes. X is greater than 1? You have got yes, but this is not true. So you can say that this is in ascending order. From this intuition, from this decision making process, you can conclude that yes, my array or my matrix is ascending order. Now you will come on the middle of the array. That's 1 2 3 4 5 6. So 1 2 3. So I'll come on this 9 and 12. Either I will proceed on 9 or I will proceed on 12. So I have come on this is even size. So I have come on 9 and 12. Now compare each 9 with x, 12 with x. I have seen that 9 and 12 in 9 and 12. 12, just think you can take 12. I have just taken 12. You can take either 9 or either 12. Okay, you have taken 12 and compare that it is equal to 12. No, it is not equal to 12. It is greater than 12. No, it is not greater than 12. Is it less than 12? Yes, it is less than 12. If this certain number is less than 12, then omit this. Forget this. Come on this. 1 5 9. So from a 6 size array, we have created a 3 size array. Now compare that is this 9 equal to x and 1 is equal to x. No, I'll not do it, sorry. Now come on the middle. Now come on the middle. 5. Say that 5 is equal to x. Yes, 5 is equal to x. So you have got your answer. Now think about if 5 is not equal to x, and if that will be like for this certain thing, you have to break and big array in a certain thing. Just think about that you have 100 number of array. In this process in algorithm 2, you have to break it in 50. After that 25. After that 12, I not use the fourth value like 12. After that 6. After that 3. And you have got something that 2, and that will be not breakable 1 and 1. That's very simple. So a big array has been broken in simplest form. So this is the theory of an algorithm of, this is the optimistic way to sort or to search and search something about an algorithm. So now, what will be the best case? The best case I have said that if the algorithm, if I have found my algorithm in the first choice, in the first position, and I have to not proceed that certain algorithm in the certain other element, so get a certain. So this is the best. And what is the worst? That if I got that got my desired element in the last of that index, that is be, that will be worst. And if I had not get the, मुझे पता ही नहीं था, मुझे वो सर्च जो करने बताया था वो नहीं है, मतलब तुमको बताया गया कि यार 1 से 100 जब जन स्टूडेंट है, पता लगाओ कि किसका कौन स्टूडेंट फेल हो चुका है, तो तुमने कहा यार कोई भी फेल नहीं हो चुका है, बट यू हैव टू सर्च टिल द वन नंबर, at first you have to sort, and then you have to sort that certain number, and you have got that there is no, so that will be the worst case. What will be the average case? The process of calculating average case all possible runtimes by number of cases. What will be the all possible number runtimes? The all possible runtimes is what? All possible runtimes is 1, 5, 9, 12, 13, 23, 56. So that will be the all possible runtimes. And what will be the number of the cases? So that will be the number of the cases. That is easy. Now, one most important term that we'll discuss, log n. In the ascending order form, you can see that there is a log n, and that log n is the optimistic, and I just said that that is the average case. So what is the log n? The log n, the concept of log n has been come from algorithm 2. So now what is log n? Just think one matter. I just क्लियरली समझने की कोशिश करो. आई थिंक ये सुनने के बाद लॉग इन के बारे में कुछ प्रॉब्लम नहीं होगा. जस्ट थिंक I have to say to derive log 8 and log 4. I have so said that break it when you have seen a number, big number, break it. So that will be like 8 by 2 plus 4 by 2 plus 2 by 2. 8, 4, 2. And it cannot be break. It cannot be break in 1 by 2. It cannot be break. So that will be the last. And it is broken by one time, and one time. So the value of log 8 is 3. Calculate it. Use your calculator and calculate it. According to the law of mathematics or law of logarithm, the value of log n is log m to the power n equal to n log n. So for log 8, that will be log 2 cube. That means 3 log 2. This is 1, so this is 3. That has been justified. हाँ या ना, सही है ना. Now log 4, you can say that go log, if log 8 is 3, then easily we can say this is log 2 upon 2, so that will be 2. I will not say, I will not believe. I will say break it. That will be 4 by 2 plus 2 by 2. This is 1, so that will be. I think there will be no issue regarding this login. And can you see one thing? Can you observe one thing? I have reduced this base, this n. So that difference between 4 and 8 is what? 4. But the number had been reduced just 1. So after increasing or reducing huge amount of value of n, the resultant has been increased a certain number. That's why login has been called average case. I think that has been understood by everyone. The change is very small. In the time complexity definition, you can say that you have read that or heard that the runtime has been, so the runtime had been uh, how the runtime increase or how the runtime decrease when increase and decrease simultaneously the value of is the theory of log, and that's why the log is called average case. Now I think that this is enough for this time and complexity page. I think that there will be no issue regarding a certain thing I have just said it here. So I'll take an easy example. Okay, I'll take an easy example. Just think about. I have said to do a certain thing that this is a for loop for I equal to. You can do. I will just make another video after this. There I will solve different problems regarding time complexity. Just comment down if you want or not. That will be n. That will be I plus plus. And there is a certain block of code. Now, what will be the time complexity? Simply the time complexity is big of n. The time complexity is big of n because that is only defined when this is being true. The certain thing is being true. That is very easy. Thanks, guys. I think that there is no problem regarding this time complexity. There is another term called space complexity. I will not discuss it with this video. Space complexity, I will discuss it with another video. But the concept regarding this time complexity is very, very, very important for interview. Or very important for the theoretical exam. I think there will be no problem regarding that things. What is Vigo? Why will you use Vigo? Why when we use big omega? When we use big theta, which is called big? Sorry, what is called big best case, worst case, and average case? How to uh, how to calculate average case? All possible runtimes by the number of cases. What is the significance of log n in our daily life or in the working life? And I will discuss another, you know, uh, I'll make another video regarding that certain examples after that. So please subscribe to my channel. I'll make many videos regarding the DSL, data structure algorithms, so what you can practice and you can make yourself better for the placements or theoretical exam. Thank you for seeing this video. See you in the next time.